Good afternoon, Sean O'Hogan here and Liam McCartan, both lecturers in DIT Bolton Street. And our talk is going to be on the worth of water. This is just to give the background. We work in DIT, and there's a website with our publications and our work. So the context of the discussion, we're going to look at the value of water, the value in water, and the worth of water. And what's driving this, the global and national drivers, are the demographic growth and urbanization, water stress, quantity and quality, reducing impact of extreme events, managing aging or lacking infrastructure, and the global scarcity of nutrients. Rural development is also an important ingredient in this, and of course the global sustainable goals. Also, three of these points are critically involved in climate change. So the key questions we're trying to ask today are: what is the value of water? What is the value in water? And what is the worth of water? So the value in water would generally be looked at as it's a life support. It allows economic activity. We can't live without it. It's an amenity. It's an amenity that generates income. It gives us energy, and it can be seen as a basic human right. Thousands that live without love, none without water. The importance of it is a life support. These are slides from Liam's work in Sierra Leone. Again, you can see them queuing up for water, not very happy. And here are the laws. No washing, no laundry, no urination, ignorant of the laws, no mercy. And these are the fines as you queue up for the water. So we can see the importance of water globally. In Ireland, we tend to think of the price of water, and that has been a political issue for the last while. Which country pays the most for water? There it is, Nauru, an island in the South Pacific. 82.84 euros per meter cubed. Why? Because there's refugee camps there, and they're supplied by bottled water. What's the cheapest? Again, subsidy. Cuba, Saudi Arabia. There's some of the prices. Denmark, Australia, Germany, UK. You can see both wastewater and drinking water charges, and you can see them right down to Saudi Arabia, India, China, where you got centralized provision. There's again, we're looking at now the value in water. I'll go over to my colleague here.
Thanks. This afternoon you get two for the price of one, so that's okay. So we've kind of been stuck in Ireland on the debate of what is the value of water. So what we're asking today is to move it on a little bit on a lot of the work we're doing at the moment is what is the value in water. And what we mean by that is used water particularly is full of resources that are embedded in the system, and they can be reclaimed, recycled into new products. So it's the resources that are embedded in the used water stream. So that is what we would say is the value in water. And to expand that a wee bit more, you know, there is a traditional approach to infrastructure developed in Ireland, which is ongoing. I'm a civil engineer and I've worked on a lot of these projects, which is linear in nature. We source water, we treat it, we use it, and we dispose of it, possibly by treating it again. It's a linear system, and if we kind of split that up a wee bit, all water that is supplied, particularly to domestics, is potable water, and we typically have wastewater and stormwater, and that's the system that is being ongoing and perpetuating in Ireland at the moment. So this circular economy, you hear a lot of words about it, I'm sure there's a lot of process engineers talk about it, which is valuing the end product and reusing it and recycling it into a new product. So if we look at that in the Irish context, what would that mean? You have multiple water sources. So depending on the use, that determines the quality of your water. You've used water and recycled water, and the only difference is the quantities and the quality in that system. And then we can reuse and implement technologies that reuse it on site, or we reclaim the nutrients, metals, materials. That's in essence what we consider the circular economy. And you know, this is not to this is a buzzword across Europe, but certain societies understand perfectly circular economy, where a waste product is not a waste product, it's the start of a new cycle, a new product cycle. So if we recognize the value in water in that context, then we look at things slightly differently. We start to look at a mix of centralized and decentralized systems that start to make economic sense. We start to look at recovering the heat, the energy, either locally or globally. We start to recover materials, salts, minerals, nutrients, and in essence recovering potable water from our existing wastewater streams. And this is the drive. We work a lot across Europe with different working groups, and this is the drive right across Europe, which is the circular economy. And the logical kind of end product of that is going towards a system which is looking at use smart water grids, where the quantity, the quality is determined by the end use.
So, how are we going to move along with this new awareness of the value in water and the value of water? How are we going to move towards the worth of water? Can we valorize it? Can we give it a value? And the value of water is similar to the value we give air and energy. So, in trying to look at what is the worth of water, we consider the value of water, life support, economic growth and existence, recreation, sustainability. The worth, the value in water is resources embedded in the used water. Water is a resource and we can abstract from it. So therefore we would say to you that the worth of water is the value in water and the value of water combined. This is backed up by the Sustainable Development Goals, ensure availability and sustainable management of water and sanitation for all. I'll give you this back again.
It's a bit like a Eurovision song. But so, you know, is that all just green bling? You know, is it all ideas? Is there any substance to it? Well, a couple of very quick case studies, and I think we're okay for time. Just to maybe illustrate some of the work ourselves and our partners are involved with. So, we talk about the value of water, which, as Sean said, is multifunctional. This is an example from one of the partners in the Netherlands. And this is in the north of the Netherlands, a place called IJsselmeer. This is a lake that's used as a fresh water supply. It's used as an ecosystem. It's an amenity value. But they've had issues in terms of eutrophication, very high density agriculture, and fish stock issues, and it being the Netherlands, it's always almost flooded. So they had a decision to make a few years ago as to how did they develop their water sources in a climate change scenario. And there was two options. One, to go for your traditional hard infrastructure approach, which would be putting in water treatment, wastewater treatment, etc. But they looked and said, okay, can we recognize the value of the total system? And what they created was what's called an inland shore, which basically is an area behind the lake that uses the natural dynamics of the system to do the scientific and engineering aspects. It's kind of hard maybe to understand. And one of their kind of big issues here was, at the very start, they designed nature into the system, rather than designing in nature, which is what we traditionally do. And it was also designed and implemented in cooperation with the local stakeholders, which is very important. And this is IJsselmeer Lake. This is the area to the back of the lake, and the inlet is up there in the corner. And in essence, what they created was a water treatment system, a wastewater treatment system. They also created it as an eco-park, so you brought people towards the solution. So it's kind of a perfect example of creating a multifunctional system. Not only that, they said, okay, let's test this for a number of years, let's look at the science behind the whole thing, and they created what they call a living lab. And you know, there's a lot of information, etc., on this. So that's an example of the value of water. The value in water, well, there's a lot of, across Europe, a lot of businesses looking at, this is the Billund biorefinery. which that kind of schematic I put up earlier about the circular economy, this is an example of it in practice, where the different reclaimable nutrients that are embedded through the system are actually being recovered. Your heat, your electricity in the form of biogas, your agricultural manure, bioplastics, phosphorus, organic fertilizer. So they call it not a wastewater treatment plant, but a biorefinery. Subtle twist. And again, there's a lot of information, a lot of companies, major companies looking and recognizing the monetary value of this waste stream, which at the moment we pump out to the Irish Sea or pump underground. So that's a perfect example of the value in water, the resources that are embedded. And finally,
so to give us an example of the worth of water, if we take Singapore, which is, as you know, is at the tail end of a peninsula in Southeast Asia. It got its independence in the late 50s from Britain together with Malaysia, and then in early 1960s went on its own and left the Malaysian Federation. And at that time, the only source of water they had besides rainwater was imported water from Malaysia. And diplomatic relations weren't great with Malaysia, so eventually the dependence on the amount of water that was being supplied by Malaysia became a price issue. And Singapore then decided that they'd have to look at what they could do. And as they say themselves, water governed every decision. Water dominated every government policy. So they started off with rainwater harvesting. And they decided initially that they'd have to protect the areas where they were capturing their rainwater. So they moved industries, they moved residents away from the areas, they had protected areas where they harvested the rainwater. And this was going on for a number of years, till some non-engineer, scratching his head at a meeting one day, said to one of the engineers, listen, you take water in from a protected area and you treat it. Why don't you take it in from any area? You still have to treat it. And based on that, they went for unprotected rainwater harvesting. Here's a park in central Singapore. So they capture every drop and they treat it. They also have a barrage to control the flows in and out. They have what they call an active, beautiful and clean scheme, where they used to keep the people away from water. The idea was to keep the public away from water. Now the idea is to bring the public along, get them involved, get them to understand, and get them to take ownership of the facilities.
Hello.
They also have what they call new water. They recycle their wastewater and their surface drainage, and they produce drinking water quality. And the big thing that they did, it wasn't the science of this, using the reverse osmosis and the filtration, microfiltration, to achieve a high quality water, that wasn't their initiative. But what they really achieved was to sell it to the public. And the public are happy to drink this water. It forms 20% of their drinking water supplies, and it also is sold to the IT industry. How do we realise the full worth of water? Well, we need government action. Not in the nanny state, we need policy, we need governance, we need people to take control of the processes, have a technology portfolio. We need legislation, we need to define the different uses of water. When does water become a waste? When did it become a resource? What are the qualities of the different qualities of the water? We need education, our end, curriculum reform and training. A holistic approach. We need to design water in rather than design water out. Most of the work that's been done by planners, by architects, is to get water away from the site where it falls. We need to change that round and bring the water in on site and use it closer to the area. And again, a multidisciplinary approach where you've got planners, you've got architects, engineers, local people. The local people know their area, they know their resources. And water must govern every decision. Okay, thank you very much.